So I have a Rotovap all set up, and I went and got some waste containers. So we will attach this flask to the Rotovap, making sure the stopcock is closed. We'll turn the pump on. Water flowing through the condenser coils looks good. I heated the water bath up to about 35. You see the water is a little less yellow than it was yesterday. So I'm going to put an adapter on there. 2440 joint to a 1922 joint. And then attach my flask. And get that rotating. Sweet spot's usually right about there for the maximum rotation. That's rotating nicely. And now I'll close the system. Open up the vacuum. You hear the pump sound change as it pulls air. Means you actually got that lined up. Ethyl, acetate, and hexane don't have the tendency to bump that ether does, so I'm going to keep an eye on it, but I probably don't need to be letting in any air. So I left the lens cap on. Hopefully that didn't obscure your view too much. But I still want to wait until, any bubbling that's going to occur in there stops bubbling. And usually I wait until I see a little condensation on the outside of the flask, indicating that solvent is starting to evaporate. Unlike ether, ethyl acetate and hexane are not so volatile that they won't condense on the coils. So this time we should actually see solvent dripping off the coils. And usually once you see solvent dripping off the coils, that means it's not going to bump and it's safe to drop your flask down. Just to submerge it, not too far. My compound's not volatile, so I'm not worried about it disappearing. So we'll just let that sit and we can dispose of our waste. And that first TLC isn't worth saving since it ran off the edge and sideways. So the organic waste obviously into the organic container, solvent waste. And then the silica gel goes in the solid waste. But it often doesn't come out of the column smoothly. So the way to get it out of the column is to stick an air hose on there and then just push it out. It comes out usually in one big glob, and then there's no need to clean the column. The column is already clean. It's very easy to get rid of the column. You do want to make sure that this end is in the solid waste before you apply the air pressure though, unless you want to end up with a face full of silica. Put the lids on those, and we will write down that we have put into the solid waste silica gel, and obviously TLC plate, plural, and ethyl acetate and hexane. And I know there's biphenyl in there as well, but just traces. Oop. Forgot to put the TLC plate into the container. Like I said, the column's clean. This will probably be good to wash along with that flask. Wrong door. Sorry. And I emptied the TLC chambers while you weren't looking. I'm going to put those 4 back. Let them finish evaporating. So we'll know when we're done when this stops dripping, and that pump sound goes back to its original. So just a little while longer. We noticed that the ketone seemed to have a smaller RF than did the alcohol, which was unexpected. And we didn't get a great separation in that 95.5. So I'm going to run a co-spot. And I'm going to run that co-spot in a more polar mixture and hopefully enhance the separation of the two spots that are close to each other, the ketone and the alcohol, so we can get a better idea if there's much ketone in the starting material that could be still contaminating our product because of the similarity of the RFs. That 95.5 mixture was an excellent mixture for finding the biphenyl, which was our major compound of concern, but not so good. Actually, I'm going to run it in a 8-to-2 mixture or 4-to-1 mixture of hexane and ethyl acetate, so significantly more polar. Should move both the alcohol and the ketone quite a bit further and hopefully enhance the separation so I can get a better idea, like I said, of how much starting material there was left over. Make sure that's dried off so I don't get any hexane in the ethyl acetate. That looks good. Five milliliters is a little bit too much solvent for one of these jars, but I can use it if I just make sure I put my spots higher up on the plate. In order to do that, I'm going to need a new jar of TLC plates, so let's run over to the stockroom and fetch that. So I left the hot plate heating while I was setting things up, so we'll be able to run our TLC. I've got 52A here, and my starting material, and my co-spot. I put that line a little higher up to make sure that it's above the level of the solvent. Check on the Rotovap here. I don't see any more dripping here. Pump sounds about like it did before. Don't see any more condensate there, so I think this is done. And raise that up. And then we want to close off the vacuum. Open up the system to let air in. I'm going to turn off the water bath. And then once there's no more air coming in, safe to stop the rotation. Take off our flask. adapter back in, and now I can open this up to the air and turn off the pump. And as usual, drain the bucket. I'm not going to drain that because it's not that full to begin with. So I can turn off my power strip. And this is clean enough that I'm just going to leave it. So we'll just let that drain. And let's go get a mass of our product. There's a lot of it. And you can see that it is virtually colorless. Nice lot of colorless liquid. Good amount of alcohol. So we can see what our percent recovery was from the column, and then also what our purified percent yield was. The stopper was not part of the tare mass, though the label was. So we're now looking at 81.033 gram, 81.033 gram with the product. And that can be stored, ready for the dehydration tomorrow. So let's run a TLC and see what the ketone looks like in this more polar 2-to-8 mixture. And it was a pretty concentrated sample, it looked like, so I'm not going to put as much on. See if I can avoid it streaking into the other one. We don't need much of our alcohol because it was a very concentrated sample. I'm going to save those TLC samples in case I want them. Stick them in the back here. So under UV light, you can see that our product is nicely UV active and our starting material is not, as we expected. And so I'm going to mark on top that this was run in a 1:4 rather than a 5:95 mixture of ethyl acetate over hexane. So I'll know which plate is which. Stick that in there. Put these guys back. So I have my timer and my paratoluene sulfonic acid ready for the dehydration, along with a pipette. I don't know where this pen came from. Stick it over here in the lost and found. Syringes from yesterday are probably dry. Cap those up and put them away. Just let that develop. Make that empty a little faster. The reason we always drain the water from this is so that the rubber gasket doesn't swell from any solvent that's pulled off into the water. It's especially important with hydrocarbon solvents like hexane and pentane and petroleum ether. These pumps are durable, but if you don't treat them right, they'll still break. Yeah, it's ready for next time. Can go a little further. Rerunning this. In this solvent mixture, the biphenyl impurity will probably go almost with an RF of 1 to the top with the solvent front. Looks good.